So today we are doing systems of inequalities. We're going to be doing graphing, but instead of y equals, it's going to be y with an inequality symbol. And so to get started, we're going to talk about what it means for a point to be a solution to an inequality. So what we're going to do is we're going to take, using just your pencil, we're going to take the 7 and put it in for x, the 4, put it in for y, into this inequality, and see if it is true. So that's going to be 4. That's greater than or equal to -2, my x is 7, plus 9. What is this right here equal? What is -2 times 7 plus 9? -5. So is this true? Is 4 greater than or equal to -5? So the line under it means this would be true if it was greater than, but it would also be true if the numbers were equal. That line adds or equal to. So, but is this true?
Yeah.
Yes, it is. Question?
I had it reversed. Sorry.
Gotcha. All right, part B. We're just using the same inequality for all of these. 3 is greater than or equal to -2 times what my x, which is -1, plus 9. This would be 2 plus 9, which is 11. Is this true? No. 3 is not greater than 11, and 3 is not equal to 11. So it is no. Yes?
Is it always going to be greater than or equal to, or is it going to be less than?
It could be any of them. I'm just basing it on the one that was given to me in the problem. So it just depends on whatever the directions ask you for. So then we have -5 is greater than or equal to -2 times 10 plus 9. What does this equal? A -11. If that negative wasn't there, it would be 29. But it's -11. Is this true? Yes, it is. -5 is bigger than -11. So we could keep plugging in points all day, but it could take some extra time. What we're going to do is we're going to graph these inequalities on our graphs, and just by looking at them, by looking at the graphs, we would be able to tell if it's a yes or a no. And we're also going to be doing systems, which means we're looking for points that would be a yes for 2 inequalities. So like number 1 down here, I have 2 inequalities. I want to know which points would be a yes for both of them. But before we do that, we're going to go over these symbols, talk about what they mean and how they're going to help us in graphing. So the first thing, do what? So the first thing, this symbol is a less than symbol. Just less than. You need to get away from thinking the alligator eats the bigger number. You've got to know, you need to memorize these symbols. This one is greater than. This one is less than, or, so it's also equal. So less than or equal to. So two numbers that are equal with this symbol would be true. And then we have greater than or equal. Yes.
Why does it really matter which side is?
Just does. Like the equal to part, that doesn't matter, because it would be true no matter, 4 less than or equal to 4, 4 greater than or equal to 4, both of those would be true. But the less than and greater than part makes a difference. Okay.
Like how do you go to less than and greater than make it?
Well, like if I have 4 is less than 5, that is true. But if I do 4 is greater than 5, that's not true. So we're looking for ones that make it true. It's either bigger than or it's less than, or it could be equal to. So then with graphing, there's some differences than when we just graph normal lines. With inequalities, for one, we don't always make a solid line. Sometimes we make a dashed line. And when we get down to these examples, I will explain that a little bit further. It helps to actually see it than for me just to explain it. But if your symbols do not have the equal to part, that means that you're going to do a dashed line. So if you have just a plain less than or just a plain greater than symbol in your inequality, we're going to graph it with a dashed line. If your inequality symbols do have the equal to part, it's going to be a solid line. Something else that we're going to do once we get with our colored pencils is we're actually going to color in parts of the graph. And again, I will explain what that means at an actual example. But the two that are less than, we shade below. So we shade under the line. The two that are greater than, we shade above the line. And you're going to need to reference this little chart with these examples. So let's look at our first problem. Y is less than negative 4/3 x minus 3. So what is the y-intercept of this line?
-3.
Negative 3. So go ahead and put your point on negative 3. And what is your slope? Yep, negative 4/3, which means I'm going to count down 4, right 3. With these graphs, I'm okay if you just get 2 points. You don't have to keep going and going and going. Now, based on this symbol, am I going to have a dashed line or a solid line?
Dashed.
It is going to be dashed, and make sure you go all the way across your graph, not just between your 2 points. And the reason I said use a pencil is because if you went ahead and went, pshoo, you could take your eraser and go back and make it look dashed. Because that's what you've always done. So it's just kind of out of habit you do that. So now take one of your lighter colored pencils, and we're going to color in part of this graph. Am I going to shade above or below? Below. Less than is below. So real lightly, it does not need to be perfect, just kind of shade in a little bit under your line. We don't have time for you to make it all perfect. Okay, you should be done already. Your next line has a y-intercept of what? 3. And a slope of 2/3. Good. So up to right 3. Two points are plenty. You don't have to keep going. Dashed or solid?
Solid.
Dashed. It does not have the equal to part, so that's what makes it dashed. Do I shade above or below? Above. So all above this line, even where you've already colored, use your second lightest color. Save your darkest one for last. Landon, did you save your darkest one for last? No. Even where it overlaps. So right up here, right here. This would be everywhere above my second line. So what this means, my first line, that's where I used the pink. So if I picked any point in this pink, it would be a yes for this first inequality. My second line, I did the blue. So any part of the blue would be a yes for the second one. What I actually care about is the section that's a yes for both. So that's going to be where your two colors overlap. That's actually your final solution. So you're going to take your darkest color, and overlap, or where your colors overlapped, and that's what you're going to color in. Now, if it's not obvious, like if one of these is not clearly darker than the others, then you can make an S and look with an arrow pointing to it. Because when you do these, you've got to make it obvious to me which one is the actual solution. What that means is that any point in that green shaded region would be yes, it would be a solution. Because these are both dashed lines, if I picked a point on one of the dashed lines, it would actually be a no. because that would be an example where I got two equal numbers, but the less than does not include the equal to part. So that's why we have a dash or maybe a solid line. Now in the directions I said determine if the point 3, 5 is a solution. So the point 3, 1, 2, 3, 1, 2, 3, 4 is actually this point right there. Is that a solution to the system?
No.
No, because it did not fall in the green region. So 3, 5 would be no. Can you give me an example of a point that is a solution, somebody?
Negative 5, 2.
Negative 5, 2. Yep, that would be a solution. And think, these graphs keep going. So there's really an infinite number of points that are solutions. But obviously we can't draw a graph that never ends. Are there any questions? Let's go to number 2. My first line has a y-intercept of what?
1.
Has a y-intercept of negative 2. Has a slope of 1. And how do I make that a fraction? I do 1 over 1. So up 1, right 1. Is this one going to be a dashed or a solid line? Solid, because it has that equal to part. Do I shade above or below? Below, because it's a less than symbol. Remember, it does not need to be, it just needs to be quick. Now the second line has a y-intercept of what? 1. And a slope of negative 2. So down to right 1. Down to right 1. Solid or dashed? Dashed. Do I shade above or below? Above. Now sometimes when your lines are a little bit more steep, like they're not pretty flat, it's hard to tell where to shade. So if you put your colored pencil on your line, if I shade above, if I just kind of go straight up, that shows me where I need to shade. And then this section right here is where my two colors overlap. Now let's look at the point 3, 5. Is that a solution? Is it a solution to the whole system? No. It would be a solution to one of my inequalities, but not to both. So it's going to be a no. Now because this is a solid line, anything from here on that fell on the solid line would also be a yes. But on the dashed line, no.
Wait, so any number that landed on the solid line?
If it had landed on the solid line and it was still part of the pink, it would still have to be part of the pink, would be a yes. Yep. So I guess like from here on. Let's go to number 3. What is my y-intercept? -1. Excellent. And a slope of 1. 1 over 1. So up 1, right 1. Solid or dashed? Solid. Above or below?
Above.
Above. Good. Let's move on to the second line. What's the y-intercept? +3 with a slope of -1. So it's down and right. Solid or dashed?
Dashed.
Yep. Dashed. Above or below? Above. And this region at the top is the section where they overlap. The point 3, 5. Right there. Is that point a solution to the system? Yes. Yeah. When we're doing 3, 5, just because that's what I put in the original directions. So I just said determine for all of them if 3, 5 works. Like I could give you this graph and then give you like 5 points, and you could, would ask you to select the solutions. So you would have to look at several to determine if they were solutions or not. That would be a good question. You on the test, it is on Google Classroom, on Google Form, so you won't actually do the whole graphing yourself. One thing that's on there is I've already graphed the lines correctly, and I have like A, B, C, D. And you would have to tell me which of those would be my final solution. So on something like that, even if I don't tell you to graph it, you might need to sketch it out just kind of real quick on your own to help you with that overlap. So you're really only focusing on your symbols. So let's go to number 4. What is the y-intercept of the first line?
3.
3. Oh, almost went on the x-intercept. And what is the slope? 1/2. So up 1, right 2. Solid or dashed? Dashed. Above or below? Below. For the second line, what's the y-intercept? -2. And the slope? -2 over 1. So down 2, right 1. Solid or dashed? Dashed. Above or below? Above. So again, this one's kind of steep, so if you're not sure, pencil on the line and go straight up. Up, 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 up. And that shows you where to shade. Because when it's steep, instead of thinking up or down, you tend to want to think left or right. And that could not always be the same. Here is the solution where they overlap. What about the 0.35? No, it's really close, but close does not matter. It's a no. So I want you to try number 5. So we'll do number 5 and then we'll stop for today. We'll finish these on Monday. But go ahead and do number 5 by yourself. This is what your number 5 should look like. You should have both dashed lines and both of them were below. So that very bottom section is the overlap, and 3, 5 was definitely not a solution.